Randomly generated data is not representative of sensor data. In the chart in front of us, we have the same sensor but implemented using two different approaches. The orange line, which looks like basically noise, is just pure random number generation between 16 and 30 degrees Celsius. This is not realistic. If your home or apartment or whatever goes from 29 degrees C and quickly drops to 17 degrees C in a span of maybe 20-30 minutes, that's not good. The blue line uses mean reversion, which is basically if your temperature starts drifting up or down, the HVAC system tries to pull it back towards set point, in this case, which is 22 degrees Celsius. Let's deep dive into the YAML. Okay. So we can generate that type of data with just a few simple line of YAML. Again, we have our max at 30 degrees Celsius with our minimum at 16 degrees Celsius and our starting point of 22 degrees C, which is our set point. And again, we're using random walk. Volatility here simply says that the data has a standard deviation of 0.3. So in reality, we can get noise between plus minus 0.9, which will represent about 99.7% of our data points. Here, mean reversion simply means as we step away from our set point, which in this case is 22 degrees Celsius, each row we try to cover that gap at about 15% at a time. Right? We don't want to go from 24 degrees C and just jump back down to 22 degrees Celsius, because that's not realistic. All right. Okay. And this is the graph or chart that I showed earlier. Again, much more realistic than this mess of a noise. And here we added chaos to our YAML, right? So, sensors aren't perfect. Somebody out on the field might have hit the sensor, which made it jump all the way to 55 degrees Celsius, then come back down. And this is what our temperatures look like per floor. Right? You can see that most of the floors and sensors start off around 22 degrees C, and throughout the day you can see a temperature going up and down, up and down, up and down. Thank you.